Out. So, next session is, sort of continuing on talking about both Postgres and MySQL, and we're going to talk about compatibility, starting with Jimmy, talking about Postgres, and then we'll turn things over to Daniel to talk about MySQL families.
Can anyone hear me? Cool. Okay, so thanks for coming to our talk with Daniel. It was great collaborating with him because we're going to be going over some important topics. I think compatibility is really important. It's a word that's thrown around semi-randomly these days. Everything is compatible with everything else, and it's usually not decided on technical merit. It's usually decided by marketing people. So this being a technical, chiefly a technical community conference, we'd like to set a few things straight and just offer our opinion on this. So my name is Jimmy Angelakos. I'm based in Edinburgh. I work for PG Edge. I've been doing things around open source for a long time. I contribute to the PostgreSQL project. I've written a book called PostgreSQL Mistakes and How to Avoid Them, and I'm the maintainer of a Postgres extension called PGStatViz.
Yeah, so I'm Daniel. I'm based in the Netherlands, and I'm actually working for PingCap on TiDB. TiDB is a MySQL compatible database. So I really care about compatibility, and I've also been working with companies that run MySQL. I've been running MySQL for a long time, so I know where compatibility matters and where it breaks down. I'm also working on the Wireshark project, on the MySQL protocol decoder. So also there, it's really important to be compatible and figure out what all the features are that we are actually using on the wire, and also to see how different connectors and server implementations all behave and talk to each other. I was also awarded the MySQL Rockstar Award in 2023, so I'm well recognized in the whole MySQL ecosystem.
So let's go over the current landscape, right? I mentioned briefly that compatibility is, let's say, point of contention. There is a lot of Postgres and MySQL compatible databases out there. The absolute success of open source databases has made this possible. Postgres and MySQL are always the top two databases, and this has caused people to want to claim compatibility with them. I think this causes a bit of user confusion when you see things like Amazon DSQL saying it's Postgres compatible when it's a non-relational database that doesn't even support sequences, triggers, views, right? So how is it compatible? I think it's reasonable for users to be confused when marketing makes these decisions, and I think this is also a source of brand dilution. When something that doesn't work as well as Postgres says it's Postgres compatible, I think that detracts from the actual merits of the PostgreSQL project. Compatibility, of course, is not yes, no, right? It's not true, false. It's not an absolute. You can be compatible with some aspects of a database and not compatible with other aspects. Now, and this is why we don't like 90% compatible or 99% compatible, because the one feature that you want may not be there. So, even within the same database, you know that different versions of the same database platform might not be 100% compatible. And as a matter of fact, Postgres says clearly that versions are not compatible between them, right? So if you have a Postgres 11 and a Postgres 12, they cannot talk to each other. So in that sense, they're not compatible. But also, we're talking about features. Features are getting added and removed all the time, and this is what makes versions not exactly compatible with one another. But what does Postgres or MySQL compatible actually mean? So from a user perspective, it's like, will my application be able to work with this database, right? I bought a piece of software that says it works with Postgres. Will it work with this Postgres compatible database? What database drivers do I need? What APIs can I use to connect to this database? Very importantly, can I replicate, right, out of this database to some other system, and can I replicate from some other system into this database? So, if it's Postgres compatible, is it replication compatible with Postgres? And if I use a cloud offering, like let's say from a hyperscaler, I buy a MySQL or Postgres compatible service, right? Is that the same experience? Is it the same as installing it myself on, let's say, bare metal? Will it work exactly in the same way? And of course, can I use the existing tools and drivers that I am used to using with this database flavor for backups, for replication, for any sort of thing? So there are two perspectives. I'm not going to talk about strict Postgres compatibility. I'm going to talk about more the project governance aspect of this thing. So as the PostgreSQL project and the PostgreSQL community, we got together to discuss this issue because we started noticing that people were saying, we're compatible with your thing. And afterwards, Daniël is going to talk about the implementation side. So how they actually made sure that TiDB was compatible with MySQL. Now, at PGConf.EU, the biggest Postgres conference in the world, which took place in Riga, in Latvia last year, we had a session that was called Establishing the PostgreSQL Standard, What's Postgres Compatible? It was a working session. We gathered opinions from the community, we discussed things, and we came to some consensus before we left there. So the goal was to define a practical framework of criteria and tests for Postgres compatibility. And people have said that, Postgres is becoming so ubiquitous that it's becoming the new Linux, because everything that's running on a database in production is most likely running on Postgres these days. So, the word standard, right? You all know that instead of having a pass or fail, like this is Postgres compatible, this is not Postgres compatible, we will have a checklist of features, and they, of course, will have weights and importance, like how important is it to be replication compatible versus have the exact same syntax for this function. We also have the realistic use case that some Postgres services are managed, right? So let's say on a hyperscaler, you wouldn't get super user access. You would get some user that they created that has some of the privileges, but wouldn't be a super user. And of course, you can't read the files from the disk. You don't have direct access. You only have access to a database connection. And also, we mentioned silent failures. It's like, okay, you accept the command create index, but does it actually create an index when you type it in, right? So everything that's in the Postgres documentation, part 2, SQL commands, I think that's all required. Even rarely used features. There is implicit behavior in Postgres that you must understand to understand compatibility. Things like insert with a select statement that does an order by. What does that do? Yes, it guarantees that the order of the select will be exactly as you specify, order by, but it doesn't guarantee that the data will get written to disk in that order. Right? So that's an implicit behavior that we understand as Postgres users, but is not specified anywhere. So data types, of course, array, byte array, JSONB, and so on. And of course, we talked about feature dependencies. So you cannot have triggers without PLSQL, PGSQL, excuse me. Of course, you must be compatible with the transaction isolation levels that Postgres offers in order to claim compatibility with Postgres. And of course, you must offer the same behavior if you claim to support the same isolation level. Error codes are a good thing to have, you know, consistency with error codes. System catalogs, of course, right? When you're using a monitoring tool, it attempts to connect to the PG catalog. So if the PG catalog isn't there in your compatible version, what is there to monitor? And a really important point, if your database allows identifiers that are 256,000 long, right? Then you can't backport that data into Postgres because you've broken compatibility by adding a feature. So, server string, it must be recognizable by existing tools. Standard drivers must work. Can you PG dump data in and out of the database in a standard way? We said the execution plans don't need to be identical, but they need to do the same thing. So if you're using a partitioned table, it must be able to prune the same way that Postgres can. So, replication compatibility, we mentioned briefly before. It must be bidirectional. It must be observable, like from standard views like PG-stat replication. And of course, any vendor extensions must not break compatibility with vanilla Postgres. So you should be able to replicate to and from a standard Postgres node. You may or may not support physical replication in the sense of taking the data files and dumping them on some other server. You may or may not support hybrid clusters, like a vanilla Postgres node and a vendor Postgres node. Can they talk to each other? Can they be part of the same HA cluster? And of course, point-in-time recovery is a key Postgres feature. And for some of these things, including point-in-time recovery, you need access to the WAL files. So we said the test suite must reside outside of the PostgreSQL code base. We're testing for compatibility against a specific version. So are you compatible with Postgres 14? Are you compatible with Postgres 17? And so forth. Vendors, of course, must provide build targets because we don't know how they build their flavor of Postgres. And of course, lastly, if you fix a Postgres bug, that doesn't mean that the
speaks the MySQL network protocol. It works, but like no one is going to be helped with this. So is that Postgres compatible? Because it just does the network protocol? I don't know. Yeah. So the examples that I built are written with Go MySQL, just some Go tooling that allows you to like build your own MySQL protocol server and do whatever you want with the backend. This is just like a fun project, but a cloud provider could do the same. They could say like, well, we have like a SQL Server in the cloud, but we make it talk to MySQL network protocol, and now we're MySQL compatible. No, you're not. So you should be really careful with what are you calling MySQL compatible and what not. So TidyB is written in Go, so there are some things that are easy to do in Go. MySQL is written in C, C++, so sometimes that makes a things a bit weird because we want to implement exactly the same thing. Our storage layer is actually written in Rust. And one of the things that's really different is like if you create a table in MySQL, you use like engine equals InnoDB. Well, with our system, that really doesn't make any sense. So we accept the syntax and ignore it. But we're really careful with accepting syntax and then ignoring it because that might break a lot of things silently, and that's not what we want. But in some cases, to just get a functional thing, you need this, because otherwise, if you do a dump from a MySQL system, you cannot load it, and that's one of the important things to do. Feature compatibility. We are really open on what features we support, what features we don't support. So that comes back to the core and optional part that we talked about before. Like we do not do any geospatial. We do have factor support. XML, for example, it's a nice feature, but no one is using it. Everyone is using JSON, so we're not supporting XML. And I think for any database vendor, it's really important to be very open. Like, if you're compatible, like, are you exactly compatible, mostly compatible? What features do you support and don't you support? Because if you're actually running an application and only then finding out, that's really a crappy user experience. So in TidyB, we try to be MySQL compatible, but we also do support sequences because sequences are very useful. But that's not in MySQL. So we implemented in a MariaDB compatible way because MariaDB did implement sequences. So then you get a bit of like a Frankenstein solution. But yeah, it's still a feature we want to implement. And we cannot just say like, well, we're not going to implement it because MySQL didn't. We are not going to limit ourselves. And I think the whole solution is still MySQL compatible because you don't have to use this feature and it's not going to break replication, etc. So a few words on like MariaDB. They originally tried to be a fully drop-in replacement for MySQL. They were using the same code base, so you could just easily take your data files, stop MySQL, start MariaDB, everything would work. Over time this changed, so now you have to export your data, import your data. Some new features that were added by MariaDB and MySQL are implemented in slightly different ways. So MariaDB is not fully MySQL compatible. They have very good documentation on like what is compatible, what's not compatible. We did have to fork the MySQL connector J for some TidyB specific authentication mechanisms, but most of our customers are using plain vanilla connector J because they're not interested in this new authentication method that we implemented. So that's a place where we are compatible, but we have one optional feature that requires us to do something different. So SQL syntax and type friction. Reserved keywords is always a pain because new versions of a database might introduce new keywords, and then suddenly your statements that were working with the previous version stop working. And when it comes to explain formats, that's one of the things where we decided not to be compatible with MySQL. So if you do an explain in TidyB, like to get the same output as MySQL would not really make sense because it's being executed in a distributed way, and like to try and morph everything to look exactly the same just doesn't help anyone because you don't get the right information. And also the explain, that's not anything that an application usually does. It's what a DBA does. And there the amount of information that you're showing is way more important than having exactly the same format. For the JSON data type, MariaDB implemented this as just a text data field, and they have functions like JSON valid and have check constraints, etc. In MySQL, this was implemented differently with the UUID data type. They implemented JSON as a JSON data type. So the JSON data type actually holds your data. If you insert, it automatically validates, etc. And then MariaDB did the exact opposite with the UUID data type. MariaDB has a UUID data type, MySQL does not, but they have functions to change things. So this is a quick demo on the difference of the explain formats. It's just a very simple query, so it doesn't give you too much things. So I will just skip over the bin log. Yeah, errors, limits, and bugs. So one of the things is that, like, of course, we are a MySQL compatible database, but we also have to have our own error messages. We try to have the same error messages for the same situation, but there might be new and different situations. But there's not really any like range of error codes that MySQL is saying that they're never going to use. So that's quite difficult to actually avoid conflicts, but we try by just using a quite high number. That was everything I had for now. Thank you. I think we have...
Do we have time for questions? No. Okay.
I think we have a little bit of time for questions.
They just said we don't. So
We don't.
you can
Sorry.
catch us outside.
Yes.